Hey everybody, so in this video we are going to talk about two different methods for graphing a line. Okay, so the first method that we're going to talk about has to do with using the intercepts. Okay, and for that reason it's usually called the intercept method for graphing. Okay, so let's go ahead and look at how we're going to graph using intercepts. So the plan is basically to find each of the intercepts. So first we'll go ahead and find the x-intercept. Okay. Then we'll find the y-intercept. Okay. Then we are going to plot each of these points separately. Okay, and then the last thing we're going to do is connect them with a line. All right, so let's go ahead and look at an example. Okay. So we're going to start with an example that's already in standard form, right? So remember, standard form is that form where everything really is on the left. Okay. Okay. So we're going to go ahead and start by doing the x-intercept first. Okay. So we know that for the x-intercept we always set y equal to 0, and it's no different in this example. So we'll have 2x plus 4 times 0 equals 12, right? 4 times 0 is 0, so I'm just going to end up with 2x equals 12, or x equals 6. Okay, and that's going to give me my intercept 6, 0. Okay. Then I'm going to go ahead and look at my y-intercept. Okay, we know for y-intercepts you always set x equal to 0, and again we're going to start exactly that way. So we'll have 2 times 0 plus 4y equals 12. Okay, 2 times 0 is 0, so I have 4y equals 12, or y equals 3. Okay, and that's going to give me my y-intercept 0, 3. Okay, so I'm going to go ahead and graph these 2 points. So the point 0, 3 is going to be up 3, 1, 2, 3. That's right here. Okay, and then my x point 6, 0, I'm going to go to the right 6. So 1, 2, 3, 4, 5, 6. That's right here. Okay, and then I'm just going to draw my graph by connecting those with a line. Okay, so I'm going to go ahead and draw my graph right through these 2 points. Let me adjust that a little bit so it's fitting better. Actually, make that a little bit easier here. So we'll have those 2 points and then our line there. Okay? So this is one example of graphing using the intercepts, okay? Now I want to do another example, and I want us to look at a function that is, we're still going to use the intercepts, but a function that's not already in the standard form, right? What if we're in a different form? Okay, so let's even look at something that's written in function notation. Okay. All right. So let's start again with our x-intercept. Okay. And for our x-intercept, we know that we're going to let y equal 0. Okay. In this case, we're not using the variable y, right? We're using the variable f of x. Okay. So we're going to set f of x equal to 0. So I have 0 equals 12 minus 3x. Okay, I'm going to add 3x to both sides and divide both sides by 3. Okay, so this is going to give me my x-intercept 4, 0. Okay. Oops, I still have my old graph over here. Okay, let's go ahead and get our graph back there. There we go. Okay, so let's go ahead and find our y-intercept. Oops. So our y-intercept, okay, we really have two choices. So I want to show you both methods for this. One thing would be just to do exactly what we've been doing and set the x coordinate equal to 0. Okay, so we would have f of 0 equals 12 minus 3 times 0. Okay. This would be 3 times 0 is 0, right? So this is just going to be 12. Okay. The other thing that we can do is we can change our equation into slope-intercept form. So we could rewrite this first as f of x equals negative 3x plus 12. Right, we're recognizing that y equals mx plus b form. And then we could immediately see that our b value equals 12. Okay, so in either case, we're going to get the y-intercept 0, 12. Okay. Now, if you look at this grid, obviously we don't have 12 units here. So we're going to have to do what's called scaling, where we make each one of these lines more than one value. So if you count this up, there's 7 of them, okay? So we can't go by ones, right? And so I think it makes sense to go by 2s. So we're going to scale this way by 2, right? And then we're just going to do the same thing with the x-axis. You don't always have to scale them the same, but in this case, I think it makes sense to. Okay. So 2, 4, 6, 8, 10, 12, right? And I'm even going to mark this as 12 so we're clear. And then I'm going to mark my x-intercept at 4, 0. So this would be 2 and then 4. Okay. All right. And then I'm going to go ahead and draw a line that connects the two, like that. Okay? There we go. Just there. All right. So this is the intercept method for graphing. Okay? So let's go ahead and talk about our second method for graphing, which instead of using intercepts, we're going to use the slope and a point. Okay? Now, the most common point to choose is people like to choose the y-intercept. Okay? So let's go ahead and look at first the plan for this. So slope and y-intercept method. Okay, so in this case, if we're going to use the slope and the y-intercept, the first thing we want to do is put the equation into slope-intercept form. Okay, then we're going to go ahead and write down the y-intercept. Okay, and the slope as a fraction. Then we're going to start by plotting the y-intercept. Okay. And then we are going to start at the y-intercept. And use the slope to move to another point. Okay. And then the last thing we're going to do is connect the 2 points with a line. Okay. All right. So let's go ahead and look at this method with an example. Okay. So we're going to start by looking at something that's already in slope-intercept form. Okay. Okay. So let's get a graph really quick here. Move that over here. All right. So let's go ahead and start by finding our slope and y-intercept. So remember, this is in the y equals mx plus b form. Okay, so this means that my slope m is going to be 4, which I can write as a fraction as 4 over 1. Okay, and my y-intercept is going to be 0, comma, b, and in this case, b is -6. Okay. So the first thing I'm going to do is go down to -6. 1, 2, 3, 4, 5, 6. Okay, here's my point 0, -6, and I'm going to mark that on my graph. Okay. then I'm going to use my slope, right? So my slope is +4 over +1. And remember, the 4 is the vertical change, and 1 is a horizontal. Okay, so starting at my y-intercept, I'm going to go up 4, 1, 2, 3, 4. Okay, and then I'm going to go right 1. And this is going to be my second point. Okay. Then I'm just going to go ahead and connect those 2 points with a line. Okay. Just like that. All right, so there's my line. All right. Let's do another example like this one. Okay. So let's get our graph in there. All right. So first we're going to look at what are the slope and y-intercept. Okay. So my slope is going to be -2/3. Okay. And then my y-intercept is going to be 0b, right, or 0, 1. Okay, so I'm going to go ahead and start by graphing the point 0, 1. That's right here. Okay, and then I want to look at how I'm going to use my slope to get the second point. Okay, so students are often confused about where to put the negative sign, and I want to say that they are both correct. You can have -2 over +3. That would reduce to -2/3, right? Or you could write this as +2 over -3, and that would also be -2/3, right? So let's look at how both of these look. Okay, so first let's look at -2 over +3. Okay, so -2 is going to be down 2, and then positive is going to be to the right. So I'm going to go to the right 1, 2, 3. So this would be my second point here. Okay. So what if instead I used this, right, where I said +2 and -3. So again, starting at my y-intercept, I would go +2 or up 2, and then negative is going to be to the left. So I would go left 1, 2, 3. Now, they do give you different points. You can see that, right? But the other thing you can see is that all 3 of those points are falling on exactly the same line, right? They all line up exactly correct. So it doesn't matter which one of these 2 interpretations you use, because you'll get exactly the same line. Okay? So that's what I wanted to talk about in this video, and I will see you in class.